friends and my dear students, welcome back to my channel Phoenix Physics. Today we are going to learn conventional current. In an electric circuit, the direction of flow of current is marked from positive terminal of the battery to negative terminal. This indicates positive charges move from positive terminal of the battery to negative terminal. This is called conventional current or simply current. Why do we call it as conventional current? In 1752, prior to electricity being identified with the electron, Franklin chose a convention regarding the direction of current flow. Franklin assumed that positive charges moved from positive terminal of the battery to negative terminal of the battery. That is why we usually mark the conventional current from positive terminal of the battery to negative terminal. But in metal, the charge carrier is the electron whose charge is negative. From this diagram, you can say the flow of electrons and the direction of current points in the opposite direction. Mathematically, a transfer of positive charges same as the transfer of negative charge in the opposite direction. In nature, lightning produces enormous amount of electric current in a short time because a high potential difference is created between the cloud and the ground. So, charges flow between the cloud and the ground. Next topic is drift velocity. You know the formula for velocity, that is distance traveled by time taken, and the unit for velocity is meter per second. Then what is drift velocity? It is nothing but an average velocity attained by the charge particle in a material due to the influence of electric field is known as drift velocity. Look at the diagram. Consider a conductor. It has large number of free electrons and it moves freely inside the conductor. If there is no electric field, these free electrons move in a random direction and it collides repeatedly with the positive ions. On an average, the number of electrons traveling in any direction will be equal to the number of electrons traveling in the opposite direction. Hence, there will not be any current. Suppose a battery is connected across the conductor. You know that this battery has potential difference. So, electric field E is created inside the conductor. This electric field exerts a force on the electrons, producing a current. How? This electric field E accelerates the electrons. So, it collides with the positive ions. Due to this collision, the direction of motion of the electron will change. We can get zigzag path of the electron. So, electrons move slowly along the conductor in the direction opposite to the electric field. This velocity is called drift velocity Vd. What is the definition for drift velocity? The average velocity occurred by the electron inside the conductor when it is subjected to an electric field E. According to Newton's second law, force is equal to ma. I need A means F by M. This is my equation 1. Know that electric field exerts force on an electron. So, F is equal to EE. Here force on the electron, so minus E. Charge of the electron is negative. So, F is equal to EE. This is my second equation. Substitute equation 2 in 1. So A is equal to minus EE by M. This is my equation 3. Then what is mean free time? It is nothing but average time between successive collision. It is denoted by the letter tau. You know the formula for acceleration. Acceleration is nothing but velocity by time. Suppose I want velocity means that is acceleration into time. This velocity is denoted by, that is drift velocity, acceleration. This time can be denoted by tau, that is mean free time. This is equation 4. Substitute equation 3 in 4. So Vd is equal to minus EE by M into tau. Just rearrange this equation, minus E tau by M into E. This is nothing but mu. What is this mu? Mu is mobility of electron. So Vd can be written as minus mu into E. All are vector quantity. So just you put the vector notation. So mu Vd is equal to minus mu into E. Suppose I need mu means you can write Vd by E. Minus Vd by E. Take modulus. So mu is equal to modulus of Vd by E. Then how do you define mobility? Mobility of the electron is defined as the magnitude of drift velocity per unit electric field. Velocity unit is meter per second. Electric field unit is volt per meter. So here volt per meter. So bring the meter unit into numerator. You can get meter square volt. This S is for second. So meter square by volt second. This is the unit for mobility of the electron. We know that electrons move slowly along the conductor in a direction opposite to the electric field. The drift velocity of the electron inside the conducting wire is 10 to the power of minus 4 meter per second. This conception is given. First one is battery is not a source of electron. You know that battery gives potential difference. Because of this potential difference, electrons move inside the conductor. So battery is not a source of electrons. It just gives potential difference only. We usually say battery has no charge. If you say like this, it means battery has lost the ability to give electrical energy. You should say, I am going to charge my mobile, not battery. In this class, we discussed about conventional current and drift velocity. We studied the definition for drift velocity, that is the average velocity occurred by the electron inside the conductor when it is subjected to electric field. Then we derived the mobility of electrons formula. Mu is equal to minus E tau by M into E. I hope this video is useful to you. If you like my video, please share and subscribe my video. Thank you.